The other day, I had a question pop in my head. Have you ever thought about how languages like English, I cannot English. Have you ever wondered about how languages like English came about? Like, it wasn't too long ago that when I thought of Old English, this is what I thought of.
Deny thy father and refuse thy name, or if thou wilt not, be but sworn my love, and I'll no longer be a Capulet.
But no, that's not Old English at all. That's barely Middle English. Old English actually sounded like this.
Whet, we gardener in yardagum per quaninga tarimi frumium huerathalingus ellen fremedon.
Like, what the hell was that? How do we go from sounding like this to sounding like this?
Well, the way people talk around here, I guess it'd be what more like you call hillbilly style or something, I guess. I don't know, just mountain talk.
For those of you that don't know, that's Popcorn. He was a moonshiner in the Appalachian Mountains that became famous. His accent is actually an older variety of my accent. Now, you may hear drastic differences in between the way he speaks and the way I speak. But you get me around my family for about 5-10 minutes, it won't be too long before you hear something like "Jeet yet," or "I better get going," or "Can you hand me out over?" But that aside, having a background in evolutionary biology, I've often wondered if languages evolve through time by a process that's analogous to natural selection. Wait, hang on just a second. Yes, sir.
Hi, I'm Steve Meyer. I direct the Center for Science and Culture at Discovery Institute.
Oh, hey, Steve. My name's TJ. I'm not sure why you got a little description bubble that popped up and I don't. Hang on just a second. Hey, Timmy. Yeah, can we add a description bubble here, like with my name and a little bit of my credentials or something, please? Because one of the students get it, but I don't. Yeah, that's good. So as you can see here, Steve, I'm TJ Rogers. I'm a postdoc at the University of North Carolina. Could you tell me a little bit about your background?
I'm a philosopher of science and a geophysicist by training.
Oh, that's really cool because I'm a microbiologist, and my background is in ecology and evolutionary biology. It's what I got my bachelor's degree in. But it's good to have you. Thank you for joining the class. If you could be seated, that'd be great.
This is a class about the theory of intelligent design.
No. Are you sure you're in the right class? Because I just looked at the roster, and you're supposed to be in here. This class is on how DNA, the genetic code, shares similarities with human language, and how both diversify and change through time. If you'll have a seat, we can carry on with the conversation, and we can move on with the topic at hand. Thank you. So, as I was saying, as an evolutionary biologist, I've often wondered if languages change through time and diversify like we see species change through time and diversify. Does language follow something that's analogous to natural selection?
Natural selection and random mutation don't seem to be a very good explanation for the origin of new genetic information.
Really? That's new information for me, Steve. Do you mind to elaborate on that a little bit?
The reason for that can be understood by reference to our own experience with digital code, with software. If you're a computer programmer, you know that if you start randomly changing the sections of functional code, you're going to degrade that code long before you ever come up with a new program or operating system.
But I'm failing to see how computer code goes along with what we're discussing here, mainly human language and biological evolution and the similarities between the two. Do you care to elaborate a little bit?
So I have a visual illustration that draws an analogy between what's going on in the chemistry and what's going on in the illustration that may make this principle clear. I have here a message written on a magnetic letterboard. The letters stick to the magnetic letterboard because of the magnets in them. Because we can actually rearrange the letters and generate not information, but gibberish. Same forces of attraction, now no information.
So, based on your analogy, you're saying that if I have a sentence written in English, or if I have a DNA sequence, and I start randomly swapping out letters or words in the sentence, or if I start swapping out randomly the nucleotides in this singular DNA strand, that eventually this will lead to
Gibberish.
Okay, Stephen, I think I see where the mistake here is, and I don't think that you've been paying attention in class. Are you beatboxing right now?
And loop that right there. Well, I can't hear you. I've got my headphones on.
Oh, come on now, Stephen. That's just disrespectful. Stephen. 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 Stephen Meyer. I'm sorry, Steve. Let me make it up to you. Can you please continue to elaborate on your example? What exactly are the problems that you see with swapping out these nucleotides or these letters in an English sentence?
Whether you're talking about digital code in a software program or a section of text in an English sentence or book, or the genetic text in DNA, there are vastly more ways to arrange the relevant characters that convey the information in a way that will produce gibberish than there are that will produce function or meaning.
Do you mean to say that no changes, no changes at all can be made with?
You can change a few things and still retain function, but after a very few number of changes, you're going to degrade the function, and long before you come up with a new function.
So if I understand correctly, let me see if I can rephrase your argument. The genetic code is analogous to human language. Languages can tolerate small amounts of change and still function as a language. For example, British English and American English, these are both forms of English, but the dialects are very different. However, too many changes in a language will cause it to degrade long before it becomes a fundamentally new language. Therefore, the genetic code will degrade long before it gives rise to new anatomical structures. So, for example, if I have this sentence here and it says, "Our Father in heaven, we honor your holy name." Now, I take that sentence and I swap the order of some of the words around. I add words, if you can call them words, in there that weren't there before. And I replace some of the letters with other letters. I mean, I can't read that and tell you what that means. What does that mean? As far as you and I are concerned as modern English speakers, that is complete gibberish. It doesn't make any sense at all. However, this first sentence and this second sentence are the very first lines in the modern English and the Old English version of the Lord's Prayer. Just for context, let's hear what the Lord's Prayer sounds like in Old English.
Fader ure, þú the erton heavenum, si din nama je halgod, tu bekuma din riche, je wurde din willa, un erdon, swa on heavenum, urna je dai chwamle kan slaf, sule us to die, and for juvus ure gultas, swa we, for juvad urem gultendum, and ne je lardu us un kostnunge, akalusus uf uvele, so liche.
Now, it doesn't take a rocket scientist to see that there are obvious differences between the Old English version and the modern English version of the Lord's Prayer. However, if Steve is correct, how can it possibly be that modern-day English came from Old English when they are drastically different from each other? I thought that, according to his idea, this would lead to gibberish. Looking at these two forms of the Lord's Prayer, we can see that some of these words are very similar. And there's just slight modifications that's changed them. So one way that language can change over time, especially from Old English to modern English, is exactly what I've spoken about before: random mutations and natural selection. In this case, the random mutations would be slight changes in the way someone pronounces a word. So back in the early medieval times, you had different populations within what we now call England. And these different populations, while there was some traveling between these populations, there were some of these populations that were more isolated than others. And you would have, over time, the way that these populations speak or enunciate certain words would differ from each other. So,
Fader ure,
became our Father,
heavenum,
became heaven,
to die,
became today. I mean, one example is in today, modern America, you go up to Boston, New York, and they're going to have a completely different accent than my country ass has. So it's not that there was a consensus one day where old English speakers were saying, well, we're going to change the letters that we use. We're going to change the way we pronounce these letters. We're going to change the way that we say vowels and expect everybody to adapt to that. That's not what happened at all. What happened was there were slow modifications over time. One thing that happened was there were slow modifications over time within distinct populations that added up to major changes and led to some of the words that we use in modern English today. So, going back to Stephen's argument, the genetic code is a language analogous to human language. Yeah, we could say that. Languages can tolerate small amounts of change and still function as a language. We can also say that as well. For example, you have British English and you have American English. These are both types of English. However, there are different ways of pronouncing certain words, as well as different ways of spelling words, such as color and color. Now, on his third point, this is where we run into trouble. Stephen claims too many changes in a language will cause it to degrade long before it becomes a fundamentally new language. We can see that's not true. There have been drastic changes from Old English to New English, and there are a lot more steps involved than just random mutation. And we'll talk about that part in the next video. So what does that mean for his conclusion? That being, the genetic code will degrade long before it gives rise to new anatomical structures. Stephen, do you think your argument holds up? Wait, where are you going? Stephen, don't leave.
Look what I can do.
Well, that was very good, but don't leave. I guess we'll pick this up next time. This video, while it was very time consuming, has been a lot of fun to make. My intentions were originally to try to put out a video every week to 2 weeks, but I don't think that's going to be possible with my schedule. So my plan for now is to try to put out a video every 3 weeks. But along the way, as I streamline the process, I hope that I can start putting out a video every week. But we'll see how that goes. Once again, thanks for watching, and I hope to see you next time.